Okay, these are the notes for section 5.2. This is where we first introduce verify problems, which we'll do a few of in this unit. A verify problem is they're going to give you an equation that is equal. It is equal. They're always going to be. None of them are false statements. What you have to do is you have to show that that is an equal statement. You have to verify that it's equal. So you have to show that the two sides are identical, that they're equivalent. Now there's some rules for it. A big important one is you can only work with one side at a time. You know, a lot of times in algebra, if you want to get rid of a 2 from one side, you can divide both sides by 2. Or if you want to get rid of a plus 3 from one side, you can subtract 3 from both sides. Right? You cannot do that with a verify problem. You can only work with one side at a time. So you can't move anything from one side to the other side. That's one of the rules. That's probably the most important rule. The general guidelines is usually start with the most complicated side first, because that's the one you can usually use the most of. You're going to use that identity sheet a lot. You're looking for something that matches an identity. Then you look for something that you can do algebra-wise. Maybe you distribute. Maybe you get common denominators and add two fractions together. Maybe you do the opposite. You have a fraction that you can split into separate fractions. If you really get stuck, a backup plan is to change everything to sine and cosine and then simplify. It's not always the short way, but if you get stuck, you can do it that way. Always you want to keep looking at the other side. Remember, your goal is to make the two sides match. So keep looking, whatever side you're working on, keep looking at the other side, thinking, okay, what can I do to make a match? You're all finished when the left side matches the right side. Okay? So we have some verify problems here. Now, some of these are kind of long. In general, verify problems aren't long. Most of them are 3 to 5 steps to get done. But some of these are longer. So let's look at this first one. So we want to verify we have tangent squared x times 1 plus cotangent squared x equals 1 minus sine squared x. So pick a side to work on. I would probably pick the left because it looks like there's a lot of stuff going on there. So I'm going to try to simplify that. One of the first things I would do is look at my identity sheet. We have a tangent squared. We have a 1 plus cotangent squared. If you look at your identity sheet, do you see anything you can use there? Well, here, notice we have one that says 1 plus cotangent squared equals cosecant squared. Well, we have a 1 plus cotangent squared right there. So maybe we want to change that. Let's take that 1 plus cotangent squared, let's change that to cosecant squared. So now this side looks like that. Now looking at the two sides, notice on the other side, the only trig function we have is a sine squared actually. Here we have a tangent squared and a cosecant squared. If we want them to match, we want them to have the same trig function. Well, since this one has a sine, let's see if we can change these to something have to do with sine. Let's see, we have tangent squared. Well, notice on our identity sheet, we have one that says tangent equals sine over cosine. Well, if tangent equals sine over cosine, then tangent squared should equal sine squared over cosine squared. So tangent squared, let's change that to sine squared over cosine squared. And we did that because on the other side we have a sine. So we would like to get some sines over here. Then we have cosecant squared. Well, from our reciprocal identity, we know that cosecant is the reciprocal of sine, so 1 over sine. So that means cosecant squared should be 1 over sine squared. So let's replace that cosecant squared with 1 over sine squared. Well, now we're multiplying two fractions. Here I have a sine squared on top and a sine squared on the bottom. I can divide top and bottom by sine squared. Now I have 1 over cosine squared. Now again, looking at the two sides, now I have a cosine squared and a sine squared. We want to look at our identities of anything that relates those two. Well, that very first Pythagorean identity says sine squared plus cosine squared equals 1. Let's see if we can use that. Like here, what if we took that and moved the sine squared to the other side? If we did that, wouldn't it say cosine squared x equals 1 minus sine squared x? Well, now let's take that 1 minus sine squared, let's change it to cosine squared. Now notice the left side and the right side match. We're done. We verified it. So essentially we did 1, 2, 3, we did 4 steps and got done. Now a lot of this will seem new to you. Just kind of, it's one of those things, the more you do, the easier it gets. Actually, as we go in the unit, the more identities we add, the easier it gets because you have more things you can lose, or that you can use. All right, let's look at this next example. Here we want to verify we have tangent theta minus cotangent theta over sine theta cosine theta. On the other side, we have secant squared theta minus cosecant squared theta. And here, I would probably start on this left side. Now, we did a practice problem like this the other day. Notice the bottom is one thing because our sine and our cosine are multiplied together. The top, we're subtracting two things. So that you could look at it and say, somehow this fraction got combined. Let's uncombine it. Let's separate that into two fractions. We can do that and say, okay, we take this first thing, tangent theta, over that denominator. You need the whole denominator, minus cotangent theta over that denominator. Just like if I gave you this, two separate fractions, said, oh, we have a common denominator, we can go ahead and subtract them and get that. We just did it back. We just did the reverse. Okay? Now, if you look at that here, when I look at that, I see sine, cosine, and I see tangent and cotangent. Let's change everything to sine and cosine. Let's see, we know our quotient identities. We know tangent equals sine over cosine. Let's change that tangent right there to sine over cosine. So on the top of that fraction, we have sine over cosine, and the bottom is still sine theta cosine theta. Let's do the same thing with the second one. We know that cotangent equals cosine over sine. Let's change that cotangent to cosine theta over sine theta, and it's still over that denominator. So it looks like that. Now, we've talked about these type of fractions quite a bit. Whenever you have a fraction within a fraction, you take the top times the reciprocal of the bottom. Let's do that. So let's take the top of this one, so sine theta over cosine theta, times the reciprocal of the bottom, that's 1 over sine theta cosine theta. So we took that fraction, took the top times the reciprocal of the bottom. Let's do the same thing here. Minus the top is cosine theta over sine theta times the reciprocal of the bottom, which is 1 over sine theta cosine theta. So we just rewrote those two fractions. Well, let's simplify. Here I have a sine and a sine. Let's divide top and bottom by sine. I'm left with 1 over cosine times cosine, cosine squared. Here I have a cosine on the top and a cosine on the bottom. Let's divide top and bottom by cosine. On the top, I'm left with 1. On the bottom, I'm left with sine squared. Now, we want to keep comparing it to the other side. So on the other side, I have secant squared minus cosecant squared. Here I have 1 over cosine squared and 1 over sine squared. Those are pretty close to being related. We know that secant equals 1 over cosine. So isn't 1 over cosine squared going to be secant squared? Here we know cosecant is 1 over sine. So wouldn't 1 over sine squared just be cosecant squared? And now the two sides match. We verified it. Again, you won't be used to doing some of these. It takes a while to get used to what it is you're doing. All right, let's look at this next one. Here on the left side, I'm adding two fractions. I have tangent over 1 plus cosine plus sine over 1 minus cosine equals cotangent plus secant cosecant. Now here is kind of the opposite of the last one. The last one we had one fraction and we separated it into two fractions because, no, I shouldn't have mentioned this before. If you notice here, we had a single fraction on the left and I had two separate things on the right. So that's a good bet if they're going to match. Either we have to combine these or split these. Same idea here. Here, notice we have two separate fractions here. On the bottom, on the right side rather, we have a lot of different stuff. Now in this one, I would probably, when I see that I'm adding two fractions, I would think about getting a common denominator. Well, here I have 1 plus cosine and 1 minus cosine. So the common denominator will be the product of those two. So the common denominator will be 1 plus cosine times 1 minus cosine. That means to get a common denominator, we need to multiply this one by the denominator of the other one. So I need to multiply tangent times 1 minus cosine x. So that'll be tangent x minus tangent x cosine x. For this second one, it already has a 1 minus cosine. I need to multiply it by the other denominator. So 1 plus cosine x. So that'll be plus sine x times 1 plus cosine x. Even though that's trig functions, that's the same thing you've done before in regular old math classes. When you want to get a common denominator, you multiply the two denominators together, take the first fraction times the other denominator, take the second fraction times the first denominator. So it looks like this. Here, if I distribute this out, I should have done that while I multiplied. That's going to be sine x plus sine x cosine x. Now, we look at that. Got a lot of stuff going on there. On the bottom, let's go ahead and FOIL those together. First times first is 1 times 1. Outside 2 would be a negative cosine x. Inside 2 would be a positive cosine x, so they'll cancel out. Last times last is a negative cosine squared x. That looks good on the bottom. On the top, I'm going to do some selective substitution here. Let's see. I see a lot of sines and cosines, and now I see a couple of tangents. Let's change these to sines and cosines. So that tangent x there, let's change that to sine x over cosine x. This tangent here, sine x over cosine x. Again, that's just from our quotient identity, right? Tangent equals sine over cosine. So again, when I look at this, I see a lot of sines and cosines in just those two tangents. So that's why I decided to change the two tangents. We still have a lot of stuff going on here. So we have all that. Now in this one right here, I have a cosine on the top and a cosine on the bottom. I can cancel those out. So now I have sine x over cosine x minus just sine x plus sine x plus sine x cosine x. Still over 1 minus cosine squared x. Well, now, let's see, I have a negative sine x and a positive sine x. Those can cancel out. So I'm left with that. Here, this 1 minus cosine squared, let's take a look at that here. Didn't we just do something like that if we took this identity right here? If I move the cosine squared to the other side, wouldn't that say 1 minus cosine squared equals sine squared? So this 1 minus cosine squared, we're going to change that to sine squared. Let's see. Now, let's split this into separate fractions. Because I have this plus this. So we'll split it back up. So here I have sine x over cosine x, all over sine squared x, plus sine x times cosine x, all over sine squared x. So let's see here, if we take the top, put mine off the paper. So up here we had a negative sine x and a positive sine x, so those canceled out. Then I split this into two separate fractions. So I have sine x over cosine x over the denominator sine squared, plus sine x times cosine x over the denominator squared. So now here, if I take the top times the reciprocal of the bottom, here, notice I have a sign on the top and a sign on the bottom. Let's divide top and bottom by sign. That'll get rid of that and one of these. I'm left with cosine x over sine x. Kind of here I have a sine x and a sine squared x. Let's divide top and bottom by sine x. That'll be 1. That'll get rid of one of these. So now here on the left I have 1 over cosine. Well, 1 over cosine is secant. I have 1 over sine. 1 over sine is cosecant. Here I have cosine over sine. Remember from our quotient identity, cosine over sine is cotangent. Now if you look at the two sides, I have secant x, cosecant x plus cotangent x. Here I had cotangent x plus secant x. So it's the same thing. We're done. That was pretty involved. There won't be any that are any harder than that one. So if it seems hard, it's all right. It should be. It is long and difficult. All right. So that's some examples of verifying. Now, this next one, these are some things that might come up when you're verifying. Like here, sometimes you might have to factor. So if you look at this, if you look at that, that's the difference of two squares. We have a secant squared minus 1 squared. Well, we factored those in algebra. If you had like x squared minus 1, we factored that as x minus 1 times x plus 1. We can do the same thing here. We have secant squared minus 1. So that factors as secant minus 1 times secant plus 1. Works just like it did in algebra. Or here, this is a trinomial. You see we have a squared, we have a sine squared, we have a sine, and we have a constant. We can factor that. Remember doing this before in algebra? So 2 sine squared factors as 2 sine x times sine x. 1 factors as 1 and 1. If you check that, let's see. First times first is 2 sine squared. The outside 2 is 2 sine x. The inside 2 is 1 sine x. That's 3 sine x. And last times last is 1. So you may have this in the middle of a verify problem where you have to factor that. This next one is another factoring one. This is one it seems students forget a lot. You see this says sine cubed plus cosine cubed. That's the sum of two cubes. If you had two cubes like a cubed plus b cubed, that factors really with a formula every time. The formula says you take the first plus the second. That's one factor. The other factor is the first one squared minus the product of the two, so AB, plus the last one squared. Seems like students never remember this, but you did actually do this in algebra. Well, we're going to do the same thing with this. Instead of a cubed plus b cubed, we have sine cubed plus cosine cubed. So sine is substituted in for a, cosine for b. So if we do the same thing, a plus b becomes sine x plus cosine x. Then we have a squared, that's sine squared. Minus ab, that's minus sine x cosine x. And plus b squared, that's plus cosine squared. So it factors like that. This one also simplifies a little bit. If you notice here, we have a sine squared plus a cosine squared. Remember from our identities, sine squared plus cosine squared equals 1. So we could actually, and then the next step would be sine squared plus cosine squared. That is 1. And then we still have minus sine x cosine x. So if you had to factor one like this, your two factors would be sine x plus cosine x and 1 minus sine x cosine x. Again, verified problems are not simple. It just takes practice and getting used to it.